Section 5.1, what is randomness? Okay, so random is when no predictable pattern occurs and no outcome is any more likely to appear than another. I think we all know what random means, but important to know here is that people in general are not good at being random. As an example, if I were asked you to write down a list of random numbers, you probably would not write a true list of random numbers. You would tend to choose numbers that mean something to you. Maybe they're your favorite numbers or birth dates or anniversaries. Numbers that mean something to you would probably come out, even though you may not realize it. So we do not like to rely on ourselves to choose things randomly or to pick random numbers. Instead, we would use something that is truly random, like we would flip a coin, use a random number table or a random number generator online or in StatCrunch to create truly random samples. Probability is used to measure how often random events occur. These are relative frequencies. So again, probabilities are usually given back in percents. There are two different kinds of probabilities. You've got empirical probability, which are frequencies that are based on an experiment or on observations. Both of those are kind of key words for empirical. One thing that helps me remember that is the E for empirical and the E for experiment. Also, another word that comes to mind just now as I'm thinking about it is if there's some sort of an action happening. That would be a clue that it's an empirical probability. For example, if I toss a coin 10 times and I get heads 6 times, then the empirical probability here of getting heads occurred 6 out of 10 times, or 60% of the time. So again, there was an action. I literally tossed the coin. There's an action. Tossing a coin is an experiment. I observed what happened in that process, and that's how I get an empirical probability. Now, theoretical probabilities are probably more of what you're thinking of when you think of toss a coin. These are the long-run relative frequencies, the relative frequency at which an event should happen after infinitely many repetitions. So if I could toss a head infinitely many times, then the theoretical probability should be 50%. Because if you toss the coin, then exactly half of them should come out as heads. We use empirical probabilities to estimate and to test theoretical probabilities. Okay, so we just want to look really quickly at a few examples and see if we can tell the difference between empirical and theoretical now. Okay, so number 1, part A just says the probability of rolling a 5 on a fair 6-sided die is 1/6. There's no action. I'm not actually doing it. This is just a theory. So this would be theoretical. I'm not performing any type of an action or an experiment there. This is just the general accepted probability for that to happen. Okay, on part B, I close my eyes and I choose a student's name off of my class roster. Well, I am choosing. There's an action that's happening. So this one's going to be empirical because there's an action or an experiment happening. Experiments for us don't have to be anything major. It just means that there has to be something that we're physically doing. Okay, the probability of choosing a king out of a standard deck of cards. This one again would be theoretical because there's no action happening right now. It's just saying in general, if I were to choose a king, what would be the probability of, or if I were to choose a card, what would be the probability that it's a king? So nothing happening right there. D, I draw a card out of a standard deck 5 times in a row and I record what card I choose each time. Well, this is different. This is different than the one above. This one, I'm actually physically doing it. I am drawing something. So that would throw this into an empirical